And welcome back. As we go ahead and take our look at our next programming language, we are now going to dive into C++. And to do that, let's go ahead and take a look at how C++ handles variables, types, and some basic I/O. So let's first start by looking at creating variables. C++ is an evolution of C, so many of the rules that we are already familiar with will apply here. So we want to create a variable. We use the same rules that we have done previously. So the type followed by the name equaling a value. So int age equals 14. We can also, of course, reassign variables very easily in their values. So age equals 18. Again, this is something that we're very familiar with in terms of some of the style and presentation. Now, in terms of the naming conventions that we have for variables in C++, much like in Java and other programming languages, there are certain rules that we should use or standards that we should follow. So, for example, a variable name can only have letters, numbers, and an underscore. A variable name cannot begin with a number. It's also preferred practice to begin variable names with a lowercase character. You'll see a lot of camel casing, for example, get used here. A variable name also can't be a keyword, so something like return is not a valid variable name. And a variable name can start with an underscore, though this is not considered a good practice, in fact, because underscores are typically used to indicate separation of words here. Now, C++, of course, also has literals. And literals, if you recall, are simply just data that's used for representing fixed values. They can be used directly in code, so I could say like 1, 2.5, the character C, etc. And they can be of several different types. So we can have integer literals, floating point, characters, escape sequences, strings. Strings is a very common one that we see because a lot of times, for example, when we are writing out to the console and we're putting just a direct quote of what we want displayed, that is a string literal right there. We, of course, can also handle constants as well. Remember, constants are variables whose value cannot be changed. And in order to do that, we use the const keyword to indicate a constant. So const int light speed equals 299792458. And if I try to change that, let's say light speed equals 2500, we're going to get an error because light speed is a variable that is set to a constant value. Here you'll notice that in this case, the keyword const is used to declare a constant named light speed. If we try to change it, of course, we get that error as we've noted above. And one other thing you might notice with constants is that we indicate these using all uppercase. This is very similar to what we have done with Java. Whenever we have a constant, will be all uppercase. Of course, with Java, we don't have a const keyword. Instead, we would say like static void, static final. All right, and the final keyword is the thing that kind of keeps it from being modified. Now, C++ also, of course, has its own data types. You can see we have ones that are very familiar to us: int, float, double, char, bool. But you also see that we have on here wchar underscore t. So this is known as a wide characters. This is used for less common characters, things that might be, for example, beyond the ASCII character set. And of course, there's also the void. Void is considered a type here as well. And its return type is, of course, just empty, which means its byte size is 0. Now, you can, of course, modify these types, and this is one of the strengths of C++, is because you can take those fundamental data types we were just looking at and use modifiers. These modifiers are things like signed, unsigned, short, and long. And we can use it to modify ints, doubles, and chars using those modifiers. So, if we look at that same chart now, but now with using it just at the modifiers, you can see now we have signed and unsigned ints. We have shorts and unsigned shorts. We have longs and unsigned longs. You have, of course, the same thing with doubles and chars. And you can see, of course, how we start looking at these values. One of the things you might notice, for example, if we look at signed and unsigned int, which is a very common one we might use, you'll notice that a signed integer is used for integers, which is equivalent to the int data type that we are familiar with. An unsigned integer, though, is used to only store positive integers. So starting at 0 and working its way up. The way to think about this, if you had an 8-bit range, this is going to be right here from like 0 to 255 because it's 256 digits, whereas this is going to be a positive and negative of 128. So again, it's the same amount of values, but this one just is going to include negatives. This one does not. So very important distinction there in case if you were looking at it, because the signed part of that is used to indicate whether or not there's positive or negative values. All right, let's talk about C++ output. In C++, Cout will send format output to standard output devices such as the screen or the console, as we have referred to it in the past. We can use the Cout object along with the this double bracket operator for displaying output. And you notice that the double bracket operator in this case is pointing to the left, so it's a left-facing bracket here. And so if we look at this example, we have Cout left double bracket. This is C++ programming. All right, and this, of course, is just simply going to print out whatever we have in that string literal. If we want to apply that now to a C++ hello world, all right, how does this work? Well, we can extend that. So let's say we have this program right here. You can see I have this little include statement here. So it's an include IO stream. And you're probably thinking, hey, this is kind of like how we use import statements in Java. And you might be correct there. But then, of course, we also have our using namespace std. And this is, of course, this is a little bit more close to that because this is using a specific set of commands that we want to use. And we'll talk a little bit more about these as we dive further in. But the important thing I want you to note is right here we have int main. This is, of course, our main method. And inside of that, we have our Cout. Again, the left-facing brackets. And then it's saying hello world. Now, one thing to note is with the hello world program, so we need to include both the IO stream and the namespace std in our program. Now, what about numeric and character output? All right, so if we want to print numbers and character variables, we can use the same Cout object that we just looked at, but without using quotation marks. So in here, I have an int num1 equals 70. I have a double num2 equals 256.783. Char ch equals the capital A. And then if you notice, we do Cout, and we're doing num1. And then we have this nl command here. And then, of course, same thing with n2, and then character right here. All right, and now you notice that this one, it says character colon. This means it's a string literal here, and then we have the word ch. So we're printing out the character A. All right, if I didn't have this in here, of course, we could just have say print ch. This is, of course, in a way you could think about like concatenating in one output with another output. So this is going to print a integer. This is printing a double. This is printing a char. And you notice that each of these there's an end L. That's a fancy way of us. You think about by saying like end line, and so that allows it to say this is the end of that line of output. And so we are expecting that it should be able to, when it does a new Cout command, it's going to put it out onto a new line. Now, what about some input? All right, so it gives us some basic things for output to work with. Well, with input, C++ uses the cin command, which is going to take formatted input from devices such as the keyboard. And if we look at how the cin command works, notice we have right-facing brackets now. All right, so we're passing it into the computer, so they're pointing in. So if we look down here, we have int num, Cout says enter an integer, and then we have cin, and then again double bracket, it says num, and then we have a Cout where it says the number is, and then we're outputting num. Notice there is no end line command here because we might want that, for example, to be having that cursor here. So it's just another way that we can handle that output. Now, what if we want to take multiple inputs? Well, if we want multiple inputs from a single prompt, we can do the following. You notice in here, when we do our cin command, we have two variables. We have a character and a num. By doing cin, I have an A and then another set of brackets and then num. So this is a way for us to get multiple inputs in a single line, much as how we can do multiple outputs in single lines. So for example, you see on our Cout here, we have character, they have another angle bracket with A and then NL. Again, same thing kind of works here with cin. So just a different way for us to kind of pass in or pass out, in this case, different inputs. All right, and so let's go ahead and look at how to actually write some of that code. And so what I'm going to do is I'm popping over into Visual Studio, which is a different IDE that we can use here. And you might, of course, if you have to set it up, is going to have to install those proper projects. But I'm just going to go ahead and create a new project here. And what I want to do is a console app, all right, because that's what we're going to be working with primarily here. You want to make sure that whatever console app you're working in is the correct language. Now, if you look at this one right now, it says C#. So I want to make sure my languages, I'm going to C++, and I'm going to choose a console application. And I'm just going to go ahead and click on Next. And then it's going to ask me, where do I want to save that? And so that's, of course, where I can choose what is the name of this. Well, I'm just going to call this, like, let's say Lab 5.1. And it's going to say, where do you want to save that? And then it's going to give it a solution name. You, of course, can modify all this, anything from the directory path to the project name, etc. Let's go ahead and just create a project here. And you can see it will populate this with some starting stuff in here. In fact, we can take a lot of this starting comments out of here because we actually don't need these in here. So I'm going to actually just delete those. And right now we have effectively a hello world program. And you can see it has moved this std right here. So it's std.cout. This is just another way for it to do it. If I go ahead and run this program, it's going to take it a second to build it. And then you can see it's opening up the debug console and it says hello world. All right, and this is simply just part of the debugging window, so we can just press enter to close that. Now, if I don't want to have to type std each time, we want to do what we saw earlier in our notes here, which was using, all right, and what were we using? We're using a specific namespace here. And what was that namespace? That was the std namespace that we, of course, were using. So std, semicolon, and you can see now I don't have to type that command there each time because it knows we're using this particular namespace. And so even if I run this again, you'll see we should still get the exact same output as what we had before. There's hello world again, perfect. Now what if I want to change this? Let's say I want to instead get some basic input. So let's just say, please enter a number. All right, so that's going to be something that we're going to write up to the console. And so now let's do a cin command. Now remember with this, we have to reverse the direction of our brackets. But before I do that, I need to, of course, have something that it's going to be stored in. So let's just create an int. I'm going to call that num. And I'm going to store this then to num. And then if I want to write this back out, let's do a cout command. And just have a string that says you entered the value. And then we're going to do another out here, and let's do now our value of num. If I go ahead and run this again one more time, here is our window. It says please enter a number. So let's just go ahead and type in 5. I'm going to hit enter, and we get you entered the value 5. Now you'll notice, of course, right here we had our 5 is of course on that same line. If I didn't want that on the same line, of course, we can just use, for example, a new line escape character, and that would, of course, easily push that value down. So now you can say when I enter a number, you'll notice that my cursor is now here on a new line. So if I enter 5 now, you can see it has now moved that down to the new line. So just something to keep in mind if you are working with cin and cout, but this should give you enough for our basic introduction to C++ as we get ready to dive deeper into how this language actually works.